All right, so example 5, we have the matrix A, B, C, and we have the matrix I. So we're asked to multiply the matrix A by the matrix B. So when you're multiplying matrices, A matters. So if I say A multiplied by B, you must put the A first. 1, 2, minus 3, 4. That's A. Multiply by B. 3, minus 2, 1, 0. All right, so now we're going to multiply the matrix A by the matrix B. Guys, whenever we're multiplying two matrices, we multiply the rows of the first matrix by the columns in the second matrix. So here's how we do this. We're going to multiply the first element in the row by the first element in the column, the second element in the row by the second element in the column. So now I'm going to multiply the top row, guys, by the left column. If I multiply the top row by the left column, I'm going to get the top left element in the answer. How do we, so in matrix A, the first element in the row is 1, the second element in the row is 2. In matrix B, the first element in the left column is 3, the second element in the left column is 1. So let's multiply row by a column. We're going to multiply the first element by the first element and the second element by the second element. So first element in the row 1 times the first element in the column 3. 1 times 3 is 3, plus the second element in the row 2 times the second element in the column 1. 2 times 1 is 2. I just multiply the top row by the left column. Now I'm going to multiply the top row by the right column. So 1, 2. So 2 minus 2 is the first element in the column. 0 is the second element in the column. You're going to multiply first by first, second by second. So 1 times minus 2 is minus 2. 2 times 0 is 0. Next, I'm going to multiply the bottom row. Let's multiply the bottom row by the right column. We're going to get the bottom right element in the answer. First element in the row times the first element in the column. So minus 3 times minus 2 is 6. Second element in the row 4 times the second element in the column 0. 4 times 0 is 0. I just multiply the bottom row by the right column. Lastly, I'm going to multiply the bottom row by the left column. Minus 3 times 3 is minus 9. First element in the row times the first element in the column. And then 4 times 1 is 4. Second element in the row times the second element in the column. So our final answer here is 5 minus 2 minus 5, 6. So the matrix product AB is 5 minus 2 minus 5, 6. Ladies, gentlemen, please do B times A. All right, so next we're doing B times A. B is 3 minus 1, sorry, minus 2, 1, 0. This is B times A, which is 1, 2, minus 3, 4. So let me know if I made an error. All right, so we're going to multiply these two matrices. Guys, whenever you're multiplying two matrices, you're going to multiply the rows of the first matrix by the columns in the second matrix. First element in the row, second element in the row. First element in the column, second element in the column. So it's going to be the first element in the row times the first element in the row times the first element in the column. So 3 times 1 is 3. 3 times 1 is 3. And then, so it's the first element in the row times the first element in the column. And then the second element in the row times the second element in the column. So that would be, so 3 times 1 is 3. And then minus 2 times minus 3 is positive 6. I just multiplied the top row by the left column. First element in the row times the first element in the column. Second element in the row times the second element in the column. Next, I'm going to multiply now the top row by the right column. So how do we multiply a row by a column? First element in the row times the first element in the column. The second element in the row times the second element in the column. So it's 3 times 2, 6. That's the first element in the row times the first element in the column. Then minus 2 times 4, that's minus 8. That's the second element in the row times the second element in the column. Next, I'm going to move now to the bottom row. First element in the row, second element in the row. So I'm going to multiply now the bottom row by the left column. I'm going to multiply the bottom row by the left column. First element in the row times the first element in the column. Second element in the row times the second element in the column. First time first, second time second. It's 1 times 1, which is 1. And then 0 times minus 3, which is still 0. And lastly, I'm going to multiply the bottom row, but this time by the right column. First element in the row times the first element in the column. 1 times 2 is 2. Second element in the row, 0, times the second element in the column, 4. 0 times 4 is still 0. So our final answer is 9 minus 2, 1, 2. So next, you need to do AB times C. Now, you already did AB, so you don't need to do it again. So it's AB times C. Please remember, you already did AB, so you don't need to do it again. All right, so next we're asked to do AB times C. So the AB in bracket is saying that you must multiply A by B first. But before we go there, well, this is AB because we did it before. AB is 5 minus 2 minus 5, 6. This is AB. I just want you to note that AB is not equal to BA. Notice this is AB and BA and they are not equal. AB is not equal to BA. So the multiplication of matrices is not commutative. When an operation is commutative, you say the order does not matter. That is not the case with matrices. With matrices, when you multiply matrices, the order matters. So the multiplication of matrices is not commutative. The multiplication of matrices is not commutative. All right, so let's do AB now times C. C is 4, 2, minus 3, minus 1. And remember, you're doing AB times C. We did AB already, so you didn't need to do it again. You just simply use it. All right, so AB times C, we're multiplying two matrices. So when we're multiplying two matrices, we multiply the rows of the first matrix by the columns in the second matrix. First element in the row, first element in the column. Second element in the row, second element in the column. Whenever you are multiplying a row by a column, you multiply the first element in the row by the first element in the column. Then the second element in the row by the second element in the column. So 5 times 4 is 20. And minus 2 times minus 3 is positive 6. 5 times 4 is 20. Minus 2 times minus 3 is positive 6. I just multiplied the top row by the left column. Next, I'm going to multiply the top row, but this time by the right column. First element in the row times the first element in the column, second element in the row times the second element in the column. So it's 5 times 2 is 10. Minus 2 times minus 1 is positive 2. I just multiplied the top row by the right column. Now I'm going to multiply the top row, but this time, sorry, the bottom row by the left column. First element in the row, second element in the row. So you're going to multiply the first element in the row by the first element in the column. Minus 5 times 4 is minus 20. And then the second element in the row by the second element in the column. So it's 6 times minus 3, which is minus 18. Lastly, I'm going to multiply the bottom row, but this time now by the right column. First element in the row times the first element in the column, minus 5 times 2, minus 10. Second element in the row times the second element in the column, 6 times minus 1 is minus 6. And so our final answer is 26, 12, minus 38, and minus 16. That is AB multiplied by C. All right, so next we're going to do A multiplied by BC. Now, the A multiplied by BC is telling me that we have to multiply B by C first. So let's do BC. B is 3 minus 2, 1, 0. This is B. C. 4, 2, minus 3, minus 1. So this is BC. So we're going to multiply rows of the first matrix by columns in the second matrix. 1, 2, 1, 2. So first element in the row times the first element in the column. So that's 3 times 4, 12. The second element in the row times the second element in the column, minus 2 times minus 3. Minus 2 times minus 3, positive 6. Next, the same top row, but this time by the left column. The first element in the row, 3 times the first element in the column, 2. 3 times 2 is 6. The second element minus in the row, minus 2, times the second element in the column, minus 1. Minus 2 times minus 1 is positive 2. Next, we're going to go bottom row, left column. So bottom row, left column. First element in the row times the first element in the column. 1 times 4 is 4. Second element in the row, 0 times the second element in the column, minus 3. 0 times minus 3 is still 0. Lastly, bottom row, but this time right column. First element in the row, 1 times the first element in the column, 2. 1 times 2 is 2. Second element in the row, 0 times the second element in the column, minus 1. 0 times minus 1 is still 0. So BC works out to be 18, 8, 4, and 2. So now A times BC, A times BC, A is 1, 2, minus 3, 4 times BC, 18, 8, 4, 2. So let's multiply row by column. First element, second element. First element, second element. 1 times 18 is 18. 2 times 4 is 8. So next, same top row, but right column. First element in the row, 1 times the first element in the column, 8. 1 times 8 is 8. Second element in the row, 2 times the second element in the column, 2. 2 2s are 4. Now let's go bottom row, left column. First element in the row, -3, times the first element in the column, 18. I think -3 times 18 is -54. Second element in the row, 4, times second element in the column, 4. 4 4s are 16. Lastly, bottom row, right column. First element in the row, -3, times the first element in the column, 8. -3 times 8 is -24. Then second element in the row, 4, times the second element in the column, 8. 4 times 2 is 8. First, second element in the row, 4, times the second element in the column, 2. 4 times 2 is 8. So up here we have, what is this, 26? 12. This is what, -38? I think it's -38, yeah. And -16. All right, what we want to do now is check it out. See how does it compare? How does this compare to this? Why they look exactly the same to me? So A, B times C is the same as what? A times BC. So the multiplication of matrices is associative. So the multiplication of matrices is not commutative, but it is associative. Guys, do B, which is A squared. And of course, A squared means A multiplied by A. When you square something, you multiply it by itself. All right, so next we are going to do A squared. And of course, A squared means A multiplied by A. So A squared, 1, 2, -3, 4. That's A multiplied by A. 1, 2, -3, 4. So again, A square means A times A, row by column. First element in the row times the first element in the column. 1 times 1 is 1. Second element in the row times the second element in the column. 2 times -3 is -6. 1 times 1, 2 times -3, which is -6. Next, top row, right column. First element in the row, 1, times the first element in the column, 2. 1 times 2 is 2. Second element in the row, 2, times the second element in the column, 4. 2 times 4 is 8. All right, next. We're going to go bottom row, left column. All right, bottom row, left column. First, second, second. -1, -3 times 1 is -3. And 4 times -3 is -12. Bottom row, next, right column. First element in the row, -3 times 2, that's -6. Second element in the row, 4 times the second element in the column 4. 4 4s are 16. The final answer is -5, 10, -15, 10. Answer is -5. A square is -5, 10, -15, 10. All right, so let's turn the page. Next, we're asked to do b squared. Very quickly, guys, do b squared. So b squared means b multiplied by b. So b, so this is 3 -2, 1, 0. That's b multiplied by b, which is 3 -2, 1, 0. B square means you're multiplying b times b. All right, so row by a column. First by first, second by second. 3 3s, 9. -2 times 1 is -2. So top row, right column, 3 times -2 is -6. First by first, -2 times 0 is 0. Now let's go bottom row. Left column. One, 2, 1, 2. 1 times 3 is 3. 0 times 1 is 0. Now bottom row, right column. One times -2 is -2. 0 times 0 is 0. So the final answer is 7 -6, 3 -2. 7 -6, 3 -2. Next, we're going to multiply a by I. So a by I, a is 1, 2, -3, 4, multiplied by I, 1, 0, 0, 1. So I is the 2 by 2 identity matrix. Row by column, 1 times 1 is 1. 2 times 0 is 0. So that's top row, left column. Now, top row, right column. 1 times 0 is 0. 2 times 1 is 2. Bottom row, left column, -1 times -3 times 1 is -3. 4 times 0 is 0. Bottom row, right column, -3 times 0 is 0. 4 times 1 is 4. So what we end up with is 1, 2, -3, 4. All right, and if you're observant, you'll see that this is what you started out with in the first place. So when I multiply A by I get back A. So we could write it as a statement that A times I is equal to A. So multiplying by the I matrix is the equivalent of multiplying by 1. When you multiply a number by 1, the number is not changed. When you multiply a matrix by the I matrix, the matrix is not changed. So A times I is still A. And lastly, I times A, 1, 0, 0, 1, I times A, 1, 2, -3, 4. When we're multiplying two matrices, we multiply the rows of the first matrix by the columns in the second matrix. First element in the row, second element in the row. First element in the column, second element in the column. We multiply the first element by the first element, second element by the second element. So 1 times 1 is 1. 0 times -3 is still 0. Now, same left row, but this time now by the right column. One times 2 is 2. 0 times 4 is still 0. So let's go now to the bottom row. Left column. Zero times 1 is 0. 1 times -3 is -3. Lastly, bottom row, right column. Zero times 2 is 0. 1 times 4 is 4. So we'll end up with 1, 2, -3, 4. And you can see that that is still A. So I multiplied by A is equal to A. So we can make a general statement that A times I is the same as I times A, which is the same as A. All right, this is important. When you multiply a matrix by the I matrix, you get back the original matrix.